Hello guys, I'm back. Imagine that you have two fluids available to you, one falling fluid and one corrosive fluid, and you need to specify your shelving tube heat exchanger. Which one of them should you consider in the tube side of your shelving tube heat exchanger? My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to have access to hundreds of contents related to chemical process engineering and plant design. Recently, my dear friend Omar Binzia tagged me in a post from Ahmed Gamal on LinkedIn. And this post is related to the selection of the fluid that should be selected to the tube side of a shelving tube heat exchanger. So let's take a look. Most of guidelines for fluid allocation in shelving tube heat exchangers considers the following: more falling fluids in tubes and more corrosive fluids in tubes. If you have two fluids, one of them high falling but not corrosive, another one not falling but corrosive, based on above guidelines, what should you locate the two fluids? Which one of the two fluids you should allocate in the tube side? So based on this problem description, let's first verify what are a falling fluid, what is a corrosive fluid, and based on that, in the point of view of the chemical process engineer that works with plant design, what kind of decision we should make. To start with, let's verify what is falling. The following definition. What's the following definition? Following is the formation of wanted material deposits on heat transfer surface during process heating and cooling. So when you are passing through your falling fluid, a fluid that produces more falling, it means that this fluid will create deposits on the surface or on the heat transfer surface. It can be in the external area of the tubes if our falling fluid is in the shell side of the heat exchanger, or it can be the deposits inside the tube side of the heat exchanger. As the falling increases, the heat transfer gets more resistance and you lose performance in your equipment. So one of the points of having the falling fluid in the tube side is about the maintenance of the equipment, because most often it's easier to clean the tubes to remove the falling than cleaning the shell, because the geometry of the tubes and the tube sheet is harder to clean. Now let's take a look in the definition of corrosive fluids. What is a corrosive fluid? A corrosive fluid is a fluid that will attack and destroy the materials with which comes in contact. So when you have a corrosive fluid and you have the wall of your shelving tube exchanger, it can be the shell or the wall of your tube, with contact with the corrosive fluid, you will lose material, and based on that, you will have the walls of your equipment thinner, and eventually you can have a hole or you can have a leakage because the corrosion of because of the contact between the corrosive fluid and the material. To avoid the leakage, you can work in the selection of a material that is resistant for the corrosion, or you will have a maintenance plan in order to time change, to shift or to replace the materials that are in contact with the corrosive fluid. So in this way, if you put your corrosive fluid in the shell side of your shelving tube heat exchanger, the corrosive fluid will be in touch with the shell side, internal side of the shell, and will be in touch with the external side of the tube. And if you need to have a material resistant to the corrosion, you will spend money with the shell and spend money with the tube. On the other hand, if you add the corrosive fluid inside your tube side, in your tube bundle, you will have the material only in touch with the corrosive fluid, and you'll be able to select a material resistant to the corrosion only for the tube side of your equipment. Now that you have the big picture, what is the best side for each one of the fluids that we are talking to? It depends on the project specifics of your plan design, because how much corrosive is this fluid, how much fouling is this fluid, it will impact the capex of your project and also the opex of your project. And you, as a chemical process engineer, first thing that you must guarantee is the performance, or it is that your equipment will work for the design conditions that it is specified, but you must look also for the capex, how much will cost the equipment, how much will be the maintenance of the equipment or the opex of the equipment, and also the safety conditions related to the process, safety conditions for the process and safety conditions for the personal environment, and etc. For this kind of question, there is no correct answer. The answer will depend on the economic analysis during plan design. In any case, what you should do as a chemical process engineer working with plan design, you will do your shell and tube heat exchanger specification data sheet, and you will do the quotation with the suppliers, and you can have the options related what happens if you add, what happens in terms of investment if you decide to use a material resistant to corrosion, or if you use a standard material that you need to replace time to time, and you can verify with the vendor what are the options in terms of cost benefits. In this way, you will be able, with the specifics of your project, to decide what is the equipment that best fits for your project. In any case, if we consider here, in my point of view, the streams, if I have a very high fouling fluid and I have a very high corrosive fluid, I would decide at the first site to use the corrosive fluid in the tube side, inside the tube, because this way I can choose a material that can be resistant, and I will only consider the tube sheet. I won't need to consider the shell side of the equipment to be resistant. And if I add the corrosive fluid in my shell side and I have some kind of roll or leakage, it will go to the environment, it will go to the process area, and eventually I can have an incident or an accident reaching some of the personnel or some of the operators of the plant. So in the point of view of safety, if I cannot have, or if I will not have a material resistant to the corrosive fluid, I would prefer to use the corrosive fluid inside the tube side of my shell and tube heat exchanger. But as I told you, this kind of problem, the correct answer depends on the characteristics, specific characteristics of your project. If you want to know how to use Aspen High-Seas process simulation software to simulate a shell and tube heat exchanger, take a look in the video that will appear to you right now. This is it, guys. I hope you like it, and I'll see you soon in the next video. Bye bye.